This lesson has to do with the inverse of trig functions. We're going to investigate sine, inverse of sine and inverse of cosine. You notice that we have a table there for sine function, and we know it's periodic. We know it's a function because it passes the vertical line test. Now what I'd like for you to do is pause the video and go ahead and write your inverse function for sine. So what we're going to have to do is to find the inverse, you're going to have to switch the x and the y value. So I went ahead and switched the x and the y values, and you have a table like this. So now the y-axis is going to be referencing the degrees. In this case, it's going to be in radians. And then the x-axis is going to be referencing the ratios. So the first order pair is 0, negative 2 pi. So I have 0, negative 2 pi. The next one is 1, negative 3 pi over 2. The next one is 0, that's negative pi. And then the next one is negative 1, negative pi over 2. And then we have 0, 0. And then we have 1 pi over 2. 0 pi, and then negative 1 is 3 pi over 2, and then we go back to 2 pi, which is 0, 2 pi. And what I'm going to do is I'm going to go ahead and graph this, and you notice the difference between the two graphs. It's like the sine wave, and it's vertically, okay? So we're going to go ahead and answer the question. Does this explain whether or not the complete inverse of sine is a function? And we would say that it is not a function because it fails the vertical line test. Remember that the vertical line test is a test that shows whether it's a function or not, whether the relation is a function or not. In this case, it is not a function because it goes, if we were to draw a vertical line, it would intersect in more than one place here on the graph. So therefore, it's not a function. So we have to do something in order for it to be considered a function. So let me write this down. We have y equals sine of x. And remember, in order to find the inverse, we switch the x and the y. So you get x equals sine of y. So in order for us to find the y value here, we're going to have to use what we call the inverse. We have to use what we call the inverse function. In this case, we're going to undo this. So what we have left is y equals the inverse of x. Okay. Now, in order for this to be classified as a function, we have to restrict the domain. So let me write this down, restrict domain. So we're going to have to restrict the domain, and so the domain will be restricted between negative 1 and 1. So let me go ahead and highlight that. The domain is going to be restricted from negative 1 to 1. So it goes from negative 1 to 1. That's our domain restriction. So let me make a note there. Domain restriction. And why do we restrict the domain? Because we want the inverse to be a function. So for this to be considered a function, we have to restrict the domain between -1 and 1. So what do you have? So it's going to be y equals, it's a capital S. The capital S indicates that the function is restricted, and it's going to be restricted between -1 and 1. Now we need to find the inverse of cosine. So just like we did with sine, we're going to switch the x and the y value. So I'm going to give you a minute to go ahead and do that. So I'm going to pause the video. So now we're going to go ahead and graph our inverse cosine. So we start at x equal 1. And we're going to go straight down to -2 pi. And then we have 0, 0 comma -3 pi over 2. Then we have -1, where it goes down to -pi. And then we have 0 and -pi over 2. Then we have 1, 0. And then we have 0, and then we have pi over 2. -1 is pi. 0 is 3 pi over 2. 1 is 2 pi. So I'm going to go ahead and graph this. And you notice it behaves just like sine. It's going to be vertically. So now we have y equals cosine of x, right? And we want to find the inverse. And just like I showed you in sine, we have x equals cosine of y. So we have to do a process that is called the inverse. So we're going to get the inverse of x is equal to, the inverse of cosine x, and then we're going to get the inverse of cosine of the right side. So the inverse cosine of cosine is just going to be y equals the inverse cosine of x. Now, in order for us to make, at this point it says explain whether or not the complete inverse of cosine is a function. We would say it's not. It's not a function because it fails the vertical line test. It fails. Therefore, we have to restrict the domain. And you notice it oscillates from -1 to 1. So we're going to go ahead and restrict the domain for it to be considered a function. And we're going to restrict it from -1. We're going to restrict it from -1 to 1. So we're just going to get that piece of the graph, and we're going to say that's the inverse cosine of x. That's a graph for inverse cosine. So we're going to restrict the domain for it to be considered a function. Okay. So we're going to restrict it from 1 to -1. That's our restriction. And just like we said before, a capital C, the capital C indicates that the function has been restricted. So this graph is called y, this is called y equals, and it's a capital C, inverse cosine of x, because we restricted the domain from -1 to 1. I'm not going to spend too much time on the inverse tangent graph. I'm just going to focus on the inverse cosine and inverse sine graph, and here's an example of the table and in the inverse. We're going to go ahead and label some special attributes of the inverse sine of x. For example, what is a minimum? In other words, what is a minimum y value? In this case, it's going to be -pi/2. What is a maximum for the inverse sine of x here? It's going to be pi/2. Next, it says to describe the domain. Of course, we restricted the domain, so it's going to go from -1 to 1. Therefore, the range will go from -pi/2 to pi/2, and that's going to be really important, because anytime that we use this function, it's going to fall between -90 and 90 degrees, or -pi/2 and pi/2. In other words, it's going to be restricted to those y values. Describe the intervals of increasing. It's increasing from -1 to 1. And we're always going from left to right. So in this case, there is no decreasing part of this graph. Determine the x-intercept. It's going to be 0, 0. Determine the y-intercept. It's going to be 0, 0. For the inverse cosine, remember it's capital C, so it's the domain is restricted. So therefore, we have a local min. In this case, the local min is 0. The local max is pi. The domain is going to be from -1 to 1. The range is from 0 to pi. And that's going to play really great importance because when we use the inverse cosine, it's going to have to fall between 0 and 180. Describe the intervals of increasing. There's none. Remember, we're going from left to right. And decreasing, it's decreasing from -1 to 1. It should have been parentheses. The other one should have been parentheses since we don't include the -1 and the 1. The x-intercept is 0, 1, 0. That's the x-intercept. And the y-intercept is 0, pi/2. It says, using the knowledge of your inverse trig functions, determine the value of the following. This is a unit circle. This is 150. This is 150 degrees. We know that the sine of 150 is opposite of hypotenuse. So if you want to find the inverse sine of 1/2, since we're getting the ratio, we're wanting the degree. So when you type this into the calculator, you're going to notice that 30 comes out instead of 150. And the reason that 30 comes out is because your domain is restricted between -1 and 1. So therefore, your range is also restricted from -90 to 90. So when you get the inverse sine of 1/2, you would think you get 150, but no, you get 30 because remember your domain is restricted. Just like cosine, just like sine, cosine, inverse cosine is restricted. So if we want to get the cosine of 225. We're going to get the cosine of 225, so we start here. So this is 180 plus another, which is 45, which gives you 225. So the cosine is going to be the adjacent over the hypotenuse, right? So you're going to write cosine, inverse cosine, and we have -1 over square root of 2. So what's going to come out? You are going to get 135 degrees, because you're not going to get 225, because remember, since our domain is restricted between -1 and 1, what you get out of the inverse function is the degree that is restricted from 0 to 180. So that's how you're going to get 135. So once again, we're going to find the inverse sine. And what I'm going to do is I'm going to get the ratio here. Sine of 4 pi over 3. In this case, it will be sine is opposite over hypotenuse, so it's going to be negative square root of 3 over 2. And if I were to put that in the calculator, you would get negative pi over 3. Reason being is remember that you have a restricted domain. It's going to fall between negative pi over 2 and pi over 2.